Good afternoon and welcome to Design Master Training. My name is David Robison. Today we are going to be looking at wire sizing in Design Master Electrical. If you're attending the training live, you can ask questions in the chat box. If you're watching the recording of the training, you can call or email your questions. Our phone number is 866-516-9497 and our email address is support@designmaster.biz. In Design Master Electrical, we have basically three ways that we size wires. We are sizing feeders one way, then we have branch circuits that we size, and kind of as a subset of branch circuits, we have equipment circuits. And those two are sized a little bit differently. First, taking a look at feeders. Feeders are wires that are connected to anything that is defined as a piece of distribution equipment. So that's all defined here in the distribution equipment section. That's panels, transformers, anything like that. It's basically anything that's not a branch circuit, which is equipment connections, light fixtures, and receptacles. So when you look at a panel, the feeder specification is in here in the bottom right-hand corner. That's always where the feeder is defined. The feeder size for the panel is always based upon the panel or distribution equipment size. So we don't actually do much in the way of automatic sizing. We just match the wire size to the size of the feeder. You can override it. So if the conductor amps is set to size automatically, it's going to match this disconnect size, but we can override that, and if you need something bigger, this would be where you go and you set it. Typically for voltage drop or something of that nature. But in terms of the software actually doing the sizing, it's just pulling it based upon the size of the equipment itself. Branch circuits, we actually do size for you based upon the load connected to the branch circuit. So when we go to a circuit in the circuiting dialog, we have the load on that circuit, and then we will size the wire and the breaker based upon that. By default, it's set up that you will get a wire and breaker that's 125% of the connected load, 125% of the continuous and 100% of the non-continuous load, as defined by the NEC. You also have the option that you can change it to just be 125% of all the load on the circuit. That's a little more conservative than what the NEC requires, but that way you don't have to be quite as precise about continuous versus non-continuous and have any possibility for errors there. Design Master will figure out the size based upon the ampacity and give you the next size bigger wire and breaker. Just as an example, if I put in a test circuit here and we put in a 10 kVA load, it will see that that's going to be 83 amps connected. 125% of that is 104 amps. So we'll get the 110 amp breaker and the corresponding 110 amp wire. Equipment connections are a special case of branch circuits where they are sized not just based upon the load, but also based upon the settings in the equipment dialog. So when you create a piece of equipment, you have the option here for the wire size. So there you have the choice for how you're going to size the wire. If you just leave it as the default option and you actually don't specify anything here, it's going to size it based upon the load. If you specify an MCA, then we will make sure that the wire is the next size larger than that MCA rather than looking at the actual load that you've defined in your loads. You can also size it based upon the branch circuit selection current if you've specified that, or size it based upon the MOCP, and then also force it to size based upon loads or based upon the breaker. Motors are a little different from regular pieces of equipment in that if the breaker size is based upon one of these motor choices, then the wire size will actually be smaller than that, and it will be based upon the load rather than upon the breaker. So normally when you choose a breaker size, unless you do something different, we will give you a corresponding wire size that matches that breaker, because the breaker is protecting the wire. So if we go to the circuiting dialog and we change this breaker size from 110 to 150, we get a larger wire. Because when you choose a larger breaker, you're going to get a larger wire by default with our software. The one exception to that is when we were looking at equipment connections, that if you are sizing your breaker as a motor, so if we've got a motor with a MOCP of 100 amps, I'm going to put a smaller load on there, put a 5 kVA motor on there. If we actually put this on the drawing and connect it, circuit that motor, we have a 60 amp breaker, which is not what I wanted. Let's try that again. Breaker, I set the MOCP, but I chose a motor, and the motor is based upon the full load amps, not the actual MOCP. So I'll set the full load amps there, and that will resize. So we have a 175 amp breaker, but we do not have a 175 amp wire because it's a motor breaker. It's seen as a motor, and so the assumption is that the motor has protection for the wire as well, so it can actually have a smaller size wire than you would otherwise have. So we have the large breaker, so it can handle the motor inrush, and then the smaller wire. That's how we size the conductors. The equipment, the grounds are sized based upon the conductor, the wire size, and the breaker size. There are two options we have in the software for sizing ground wires. We can size it based upon NEC 250-122, which is the equipment grounding conductor. We also can size based upon 250-102, the supply side bonding jumper or the service ground. Typically, this will be set to size automatically, and what this means is that we will actually make the choice based upon what the distribution equipment is connected to. So if you have a panel that is connected to a transformer or connected to the utility, you'll get a service ground. Anything else, and you will get an equipment ground. And then all branch circuits always use the equipment ground as their default sizing. You can always also choose to override that, so you can give it the specific ground size. New in the most recent release, when you upsize your conductors for wire size, we upsize the ground proportionally as well. Previously, we didn't adjust the ground. So if you upsized your conductors, you needed to upsize the ground as well. Now we do that automatically, and it's proportional to the change in the conductor size, which can lead to some unexpected results if you're not really thinking through all of the different changes. To demonstrate that, I'm going to put a small load on here. So this is a 20 amp load, and it's using number 12 wire. If we have to upsize that from number 12 to number 10, it's actually going to give us a number 10 ground, because we have to upsize the ground proportionally to the size of the wire. Even more extreme, say we go with a 100 amp feeder conductor on this, it's going to size the ground to a number 1 ground as well, because that's how that piece of the NEC is written, that you have to upsize the ground to match. If we set the breaker, if we said, okay, this is actually a 100 amp load, so we need a 100 amp breaker, you actually get a number 8 ground. So we basically key off the breaker size and say that's probably what the load was intended to be, and so if the conductor amps are bigger, then we actually did the upsize, so we need to upsize the ground proportionally. All of the sizes for wires are set in the wire sizing customization. So if we go take a look at the wire sizing in our project list, for a specific ampacity, you specify what the wire size is and what the ground sizes are, and then also the corresponding impedance values. We have defaults that we ship with the software, but you can override it because different people like to size ampacities differently. The most common one, the 400 amp feeder. So we have a single run of 600 kc mil wire is what we have by default. You might look at that and say, well, I don't like to run 600 kc mil, that's too big. So if you wanted to change that, you could adjust this and do 2 runs of 3/0 wire. So make that 3/0, set that to 2 parallel runs. When you do that, you also need to adjust your X and ER values to match this wire size, because we don't do that automatically, because it's based on more than just the wire size. It's the material, it's the actual conduit type, and rather than just have this huge long list of inputs, it was easier to just have you kind of do that off to the side and figure out what the impedance values are. And you need to take into account the number of parallel runs. So looking at the number 3 up here, it's 0.042, so it's going to be half of that, 0.021, and then 0.077. So now we have our new configuration for the 400 amps that has 2 parallel runs of number 3 conductors. Now in the same way, the actual service ground and the equipment ground that is chosen for any size is based upon what these are. So we would actually want to change these to match that smaller size there as well. So that is an overview of how the wire sizing works in Design Master Electrical. If you have any questions, you can put them down here in the chat box. Thank you for watching today's Design Master training. Contact us with questions or comments by calling 866-516-9497 or emailing support@designmaster.biz.